Number 41. We don't like to split it up until that negative, until the pink box is by itself. So I'm going to move the negative over. I'm going to divide both sides by -1. I need to write as small as I can on this problem because the checking becomes a nightmare. Whoops, that's not right. What did I mess up? Yeah, the 20 should be negative as well. So that means, again, don't mess with anything in the absolute value bars. 2z plus 4 equals negative 8z minus 20. Or 2z plus 4 equals, what's my other option? I don't want to mess with the inside. I don't want to mess with the 2z plus 4. I want to mess with the other side. So I'll change the other side, change those signs to 8z plus 20. Right, leave the absolute value stuff alone because whatever's in the absolute value bar is either equal to the positive or negative of the answer. Okay, now I've got two relatively easy questions to solve, maybe. 10z equals negative 24. If I divide by 10 to get z by itself, I'm trying to save space. 24 over 10 is 12 over 5. That's going to be fun to check. I think maybe I mentioned this yesterday. It's kind of your choice. You could check it now, or you could solve the other one and then check them both. Whatever you like. My brain's kind of in solve mode, so I think I want to jump over and solve the other one and then check both. But if you wanted to work this particular solution all the way to the end, that makes sense too. Okay, subtract 2z to get 6z, subtract the 20 to get negative 16. And negative 16 over 6 would be negative 8 over 3. Great, two fractions to check. When I check them, where do I check them? All the way back at the top. If you check them somewhere other than that, you might get an answer that works and shouldn't work. So make sure you're checking all the way back at the beginning. So 8 times negative 12 fifths plus 20 equals negative 2 times negative 12 fifths plus 4. Oh, that's going to be lovely. Anybody remember their multiplication tables up to 12 like you were supposed to learn in 3rd grade? 12 times 8? 96. Good job. So 96 over 5 plus common denominator, trying to save space here, plus 100 over 5. Yeah, 100 over 5 is 20. That makes sense. And I'm out of space, but there's again, in math, we want you to have your brain turned on. We don't want you to memorize a process that you use every time. We want you to understand what's going on. Negative 96 plus 100 is going to be positive 4 fifths. And on the other side, I have negative absolute value. What kind of number is absolute value always going to give me? Positive. And if I put a negative on it, there's no way that's going to equal 4 fifths. All right? Negative, whatever this is positive, is never going to be positive 4 fifths. So I'm not even going to do all that because it's not going to be 4 fifths. So negative 12 fifths does not work. It's extraneous. Oh, I don't want to box it either because it doesn't work. Right. My guess is 8/3 will work, or negative 8/3, but let's see. 8 times negative 8/3 plus 20 equals negative 2 times negative 8/3 plus 4. Oh man, almost out of room. Let's see, negative 64/3 plus 60 thirds. That's negative 4 thirds, so I'm at least got a possibility here. If that right-hand side will be negative 4 thirds. Let's see, that would be negative 16 thirds plus 12 thirds. If I change 4 into thirds, 12 thirds. Oh, all the negative signs. I got to be careful here. Negative 16 plus 12. Negative 4. But absolute value makes it positive 4 thirds. But then a negative sign out front of that makes it negative 4 thirds. So that one did work. So that one was kind of yucky because of all the fractions. Tight on space. Let's do 47. I don't really like 47 and 49, but that's why I'm going to do 47, and then I think that'll make 49 easier for you. Determine whether each statement is sometimes, always, or never true. Explain your reasoning. Well, we've not done absolute value inequalities yet, so this is like not fair. So instead of taking an algebra approach and figuring stuff out, I think I'm just going to make a table and see if it's true or not. So I'm going to pick some values that make this true, and then I'll see if the other statement is true. So it's kind of just a guess and check, the equivalent of a guess and check type problem. So I need a number whose absolute value is more than 7. 8. Yeah, 7 doesn't qualify, but 8 would qualify. So let's pick one more, just to make sure we didn't hit some special that works, but not 9. Okay. But the absolute value means there could be other things that are answers here. What else could I plug in there that would give me? Yeah, let's try negative 8 and negative 9. All right, so I know those are true for the first statement, like if, then, so if, I got the if part. We picked values that are true for that. Now let's check and see what happens on the other side. If A is 8, 8 plus 3 is 11, absolute value of 11 is 11. Is that greater than 10? Yep. Let's try 9. 9 plus 3 is 12, absolute value is 12. That's greater than 10, so I'm feeling good about those. Let's try the negatives. Negative 8 plus 3, negative 5, absolute value of negative 5. Is that greater than 10? No. Okay, so I really don't need to plug in the last one because I've already got my answer. Sometimes, always, or never. What? Sometimes. $49, it helps you it's easier to start. If y is between 1 and 5. So what do you think we should pick for y?
3.
Let's pick several things between 1 and 5. Pick as many as you need until you convince yourself what the answer is. So I would still set it up kind of the same way. So plug in 1 through 5. Get an answer for this part, and then answer if that's less than or equal to 2, and then you'll know with your yeses and nos if it's always, sometimes, or never. Okay, your job today